Example 2 is going to ask us to go ahead and utilize all of our new, remember we already did cosine in the previous video, but new trig functions for both sum and the difference. Okay, so go ahead and pause it. If you want to try all three of these, go for it, but it's merely just rewriting and then evaluating, because this time they're not two given angles. You can see this one is unknown, unknown, unknown. And whether they use x or theta, again, totally dependent on either the angle measurement, which here they're usually going to use theta, and then for radians, typically they'll use x. But since we're doing 3 parts, I just chose all 3 to be theta so that you know I want you to rewrite all of these functions with just that by itself. Okay, so go ahead and try them, then I'll go over it with you. All right, so hopefully you recognize that this is the sine of a plus b. And if you have that memorized, the sine of a plus b, then we can go ahead and start rewriting using our identity, what it's equivalent to. So the sine of a plus b is sine a cosine of b. Sine, remember, is y, so we'll y's, listen to it. And then sine a cos b, sine b cos a. And all we then have to do is take each of those two things, the sine of 120 and the cosine of 120, that they actually gave us to work with, and evaluate them. Okay, so remember what quadrant that would be in, because some things will be positive and some will be negative. And then we'll evaluate. So I'm going to do a quick little drawing up here, and I'm going to go 180 and then back 60 degrees to do that 120 to get to that point. All right, so I know that the only thing that's going to be positive is the sine. And so now I will evaluate to get root 3 over 2 for the sine of 120, and the cosine, which again our reference angle is 60 degrees there, would be the 1/2. Just don't lose the negative, because we're in quadrant 2, because we're actually evaluating 120. All right? So to be able to rewrite this just a bit, we can go ahead and multiply straight across, and we will get square root of 3 times cosine theta over 2. Positive times a negative will be a negative, and then the sine of theta over 2. So my final answer would allow me to keep the common denominator and rewrite it as the square root of 3 times the cosine of theta minus the sine of theta. And that's as nice as it's going to get. So go ahead and try parts B and C if you haven't already, but very similar. Just be careful with your signs. No pun intended. All right, tangent of theta plus 3 pi. So that means, remember, you cannot distribute a trig function. This is the a plus b identity, the sum identity for tangent, which would yield. So remember, what we're trying to evaluate is the one that we actually can. We don't know what theta is, so those are going to stay. So the only thing we need to evaluate is the tangent of 3 pi, which means we need to know where that is on our unit circle. So remember, 1 pi is there, 2 pi is there, so 3 pi would be right back at that 180 or pi degrees. Okay, having gone around 2 pi already. Okay, so now that we know that, and we're dealing with tangent, which is the y over the x, we know we're at the point -1, 0. And since tangent is the y over the x, we'll get a 0, which is really, really nice, because that means this and that go to 0. And if we're adding 0, then that just leaves us with tangent theta plus 0, or tangent theta on top. And when we're multiplying by a 0, it will wipe out all of that. And so we'll have 1 minus 0 on bottom, which means our final answer to that is simply tangent theta. So that worked out really nice and clean. Hopefully you're able to come up with that before I did, and even went on to try part C. So let's try that one now together. If you haven't already tried it, go ahead and pause it if you'd like. Otherwise, this is what you'd have to rewrite it as. Again, being very careful and paying attention to your sign. Sine of A minus B is going to be the sine of A cosine of B. Remember, sine is the y, so y's are y's. We listen to their signs. And we will then do the sine of B cosine of A. And of course, the only things that we will actually be able to figure out are those 270s for both sine and cosine. And hopefully you recognize where 270 is. That is one of our multiples of 90, a quadrantal angle. That would be 390s, which is at the point 0, negative 1. Remember, on the unit circle, cosine is the x, so that would be the 0. And the sine is the y, which, careful, would be a negative 1. And we love it when we're multiplying by 0, because then that means the whole thing goes to 0. And then again, be very careful with the double negatives there. That would give us a positive, and we know 1 times anything is itself. So our final answer for this problem would be cosine theta. All right, so just simplifying these using our sum and difference identities for both sine and tangent. So again, this is for anyone that would like to try another on their own, or even see me do another example. But again, you can see it's very similar. The one difference is I'm going to do the sum rather than the difference of two angles. Okay, so a lot of times they're going to give you 2 so that you can work this out. And remember, they're going to also have to tell you where it is in one way or another. All right, so I'm going to go off to the side here and I'm going to go ahead and draw it. If you'd like to go ahead and pause it and try this one on your own from start to finish, there is a part C. I do want to know the quadrant of it. By it, I mean A plus B again. So I always like to start by drawing it. You could also start by just rewriting the sign of A plus B, but I'm going to go ahead and start here because I already know what I'm going to have to do in order to find these two things. Okay, so I know that A, my angle, was between pi over 2 and pi. So we're in quadrant 2. Then I'm going to do angle B, which is between pi and 3 pi over 2 in quadrant 3. And I also know what things are going to be positive and what are going to be negative based on their direction. So I'll go ahead and fill all those in so that I don't accidentally leave one of those out and make a mistake somewhere. Okay, next I'll go ahead and take what they gave me and fill that in. And since it's sine, I know that this is a y and this is an r. So going to angle A, I will say that my y is 4, my r is 5. So you should already know that this is a Pythagorean triple, and my x is a 3, 4, 5. Okay. Next, I'll go to angle B, and because it's cosine, I know that this is an x over r, and I already took care of the negative there. So the x would be a negative 5, which we already have the negative out in front, and the r would be 13. And again, hopefully you recognize that this is a Pythagorean triple, and you would be able to skip having to do the Pythagorean theorem, which shouldn't take you too long, but it is longer than just memorizing it. So this would be a 5, what, 13? 12. And now I know everything I would need to for angle A and angle B. So now I'll just start by rewriting the sine of A plus B and the tangent of A plus B. So that would yield. And now that I have these all set up, I know that I'm simply going to find each of their values. We call it evaluating, so that we can simplify this mess. So I'll start with the sine of A plus B. Some of these they've already given us, others we're going to have to find. So they already gave me that the sine of A is 4/5 and the cosine of B is negative 5/13. So all we would have to come up with on our own, which is why we did what we did over here, is the sine of B and the cosine of A. Just make sure you're playing in the proper places or quadrants. So the sine of B is the y over the r, which would be negative 12 over 13. Remember, don't lose your signs. And then the cosine of A would be the x over the r, which would be negative 3/5. And that's basically it. All you have to then do is multiply and add, which I already have set up, my common denominators. So that would give me negative 20 over 65. Two negatives multiplied together will be positive, and then that would be 36 over 65 for a total of 16 over 65. That would be my final answer for the sine of A plus B without ever even knowing what those two angles are. Pretty cool. Now I'll do almost the same thing, but for tangent. And for tangent, we know that we're going to have to evaluate only two things now rather than four. But they didn't give us any of those, so we have to find them. So the first one, what is the tangent of A? A is here, so it's the y over the x, or opposite over adjacent, and that would be negative, don't lose your sign, 4/3, which I know is the same as that tangent of A. Then the tangent of B, again playing in the proper quadrants, the proper triangle, the y over the x, which would be negative 12 over negative 5, or positive 12/5, because of the negative over the negative. Now the hard part that most students struggle with is merely the simplifying, the algebraic part. Okay? Needing common denominators and all that, again, you can attack these however you see fit, but I'm going to go ahead and rewrite this. Without the parentheses and changing those two negatives multiplied together to a positive, and then multiplying these so that I can then take this and multiply it by that fancy one of my common denominator of both the top and the bottom of 15. The LCD, we call it, the least common denominator. I'm going to multiply by 15 to everything on top and bottom. So doing that to all of these parts, don't forget to do it to the one, would give me, that would cancel to be 3 into that would be 5. So I got that times that, which would give me my negative 20. Distributing here, that would cancel to be a 3. So I had 3 times 12, which gave me the 36. 15 times the 1 is 15. 15s here would cancel to just be 48. So simplifying that, I would end up with a 16 on top, and 15 plus 48 is 63 on bottom. So that I know does not have any common factors, because 16 is 4 times 4, which are just a bunch of 2's, and 63 is not even. So I know that this is my final answer for the tangent of that A plus B. And so therefore, because we found that both sine was positive and tangent was positive, what would we be able to find for the quadrant of A plus B? Where is the only place that both sine and tangent are positive? Definitely not in quadrant 4. Here and here are individually So that would mean it would have to be in quadrant 1. Okay, so hopefully that extra one helped anybody that maybe needed to see it again. Those are definitely the most difficult in this section, but like I said, a big puzzle. Hopefully you enjoy puzzles, because that's what a lot of math is just finding the right pieces and using them in the right place. Okay, keep working hard, you guys. I know this is a little bit trickier than some of the stuff we've done before in Trig, because it's more algebraic in nature, but if you practice it enough, it will get easier. Right? Hang in there. I'm here for you. Let's keep working hard. Until the next time, Alan out.